The next type of factoring we're going to do is when we have a difference of two squares. And you'll know this because, as you can see from all the examples that I have here, that this is a perfect square, this is a perfect square, this is a perfect, this one is a special one we're going to get to, but this is, and this is as well. You'll see that all of them are perfect squares, so in other words, if we took the square root, we'd get a nice pretty number. When you have that, there's a rule we follow, and that is that if you have the difference of squares, in other words, a squared minus b squared, your answer is going to go into a minus b times a plus b. So I look here and I take the square root of both numbers to get that. So I know I'm going to have something times something, and our a is x squared. If I square root that, I get x. So I put two x's because x times x is x squared. And then I have this minus 81, so I know that this is plus and this is minus, and the square root of 81 is 9. Now to check this, best to check your work to make sure it goes together well. X times x is x squared, minus 9x plus 9x minus 81, plus 9x minus 9x drops out, and you get 80x squared minus 81. Now the other thing you want to notice from the first video is that this and this are identical except for our symbols, which means that we have conjugates, which is why it works out with a difference of squares. Moving on to the next example, I see that I have 9y squared. If I square root 9, I get 3. And square root of y squared is y. So I have 3y and 3y. I have plus and I have minus. And then square root of 25 is 5 times 5. So 3y plus 5, 3y minus 5. If we check it, 3y times 3y is 9y squared. 3y times negative 5 is negative 15y. 5 times 3y is 15y, so those will cancel. And 5 times negative 5 is negative 25. Moving on to the next one. This one looks a little different because we don't have the variable term first, but that is okay. The square root of 1 is 1. And then we have plus and minus. And the square root of 49 is 7. Square root of p squared is p. I check that out. 1 times 1 is 1. 1 times 7p is negative 7p and 7p. They cancel out. 7p and negative 7p is negative 49p squared. This next one, it is special because, as you can see, 12 is not a perfect square and neither is 27. However, remember to always factor out the GCF first, if possible. So if we look at this one, I see that 12 and 27, they have a common factor of 3. So if I factor out a 3, 12 divided by 3 is 4, so now I have 4x squared. 27 divided by 3 is 9, so now I have 4x squared minus 9. So now, when I go to do this, I still have the 3 out front. And then when I go to factor, I get the square root of 4x squared, which is 2x. And then I have a plus and a minus, and the square root of 9 is 3. Moving on to the last problem. 2x minus 1, the quantity squared, minus 25. The beautiful part about this is, despite the fact that this part looks messy, 2x minus 1 squared, if you square root that, you get 2x minus 1. So this is going to be still factoring, but we will have the quantity 2x minus 1 square rooted, so that's 2x minus 1 and 2x minus 1. And then we have a plus and a minus. and then the square root of 25 is 5. Now, if you wanted to simplify this and say 2x plus 4 times 2x minus 6, because being that this is plus 4 and this is minus 6, you can go ahead and do that. I will not require it as long as you have the proper double parentheses in there like you need to have.